Welcome to my video on theoretical and experimental probability homework. So question number 1 says, what is the theoretical of selecting B? So I know there's something up here, but up here it's saying that this is done 30 times. So that's talking about the experiment. I want to know theoretical. So theoretical is what's supposed to happen. So look at the cards. How many are B? 1. And how many total cards are there? 6. So that's all you had to do for the theoretical. It's 1, 6. Okay? Theoretical is what's supposed to happen. So that's what's in the bag, what's in the deck of cards, what's in the box, what's in the bowl, whatever it may be. Okay, now the experimental, they have to tell me about an experiment, and they do right here. So it's done 30 times, and they selected a B 7 times. So that would be 7 out of 30. Okay, now number 3 would probably make a little more sense had you been in class to do the experiment. But in the video on experimental probability, you should have heard something called the law of large numbers. So the law of large numbers says the more times you conduct an experiment, the closer that the experimental probability will get to the theoretical. So in other words, what's supposed to happen. So it says, how would the theoretical compare if we did it 1,000 more times? You should have said something to the effect that the experimental would be closer to the theoretical probability if it was done 1,000 more times. Okay? You didn't have to write any fractions or anything like that. I was just looking for basically the definition of the law of large numbers. Okay? Now, when you do an experiment, sometimes you might land, sometimes you get lucky and you land on exactly, okay? But usually when you do a small number of trials, you're not always going to land on the theoretical probability, okay? For example, if you flip a coin, you might get 5 out of 10, which is 1/2, which is what's supposed to happen. But a lot of times you'll get 4 out of 10, which is 40%. You'll get 3 out of 10, maybe 6 out of 10, 7 out of 10. But if we flip that coin 100 times or 500 times or 1,000 times, we would get pretty close to 50%. Okay, let's look at number 4. So it's asking us to compare the two probabilities, and it's the two probabilities of a multiple of 3. So remember, multiples are the product of the number and an integer. So multiples of 3 are 3, 6, 9, 12, 15, etc. Well, on a die, there are only 2, 3 and 6. Well, look at the experiment, though. They landed on a 3 4 times, and they landed on a 6 8 times. So I have to add those up. So the experimental would be 12 out of 30. I know they did it 30 times. Now notice that's not simplified. So I could divide top and bottom by 6. 12 divided by 6 is 2, and 30 divided by 6 is 5. Now, people always ask me, Mr. Rennie, I divided by 2 and then divided by 3. Exactly. You did the same thing. Now, the reason why I only have one step is because I use the greatest common factor. If you use 2 and then divide that by 3, you'll still get the simplified answer of 2/5. But if you want only one step, you pick the greatest common factor. Okay? Now, look here, the experimental probability, they didn't simplify it, but I know that this is the same as my 2/5. So it could be this one. Theoretical, nope. Experimental is not 1/3. So that must mean the theoretical is 1/3. So it's either A or D. And let me show you why it's 1/3. So here are multiples of 3 on a die. So how many choices is that? 2. And how many sides on a die? 6. So the theoretical is 2 out of 6. And I divide top and bottom by 2. And I get 1/3. Okay. Now I can use the percents or decimals to compare these. Okay. I know that the decimal for 1/3 is 0.3 repeating. You might have that memorized. But if you don't, you could just do 1 divided by 3 in your calculator and it would be 0.3 repeating. Remember to change a decimal to a percent, we can move it 2 to the right. So 1, 2. So it'd be 33.3 repeating percent. Okay. And then 2/5, you might have this one memorized. So 0.4. But if you don't, you could type it into your calculator, move it to the right, and that's 40%. So notice theoretical is less than the experimental. So the theoretical is less than the experimental, it's A. Now look what D says. The experimental is less? No, the experimental is greater than the theoretical. Okay? So that one was a little tricky and required a lot of work. Now look at the last one. It wants to know experimental of landing on a multiple of 4. Now look, I don't even need to look at this. If it said theoretical, then I would look at this, what's on the spinner. But I'm not even going to look at that because it tells me right here, this is the experiment, 45 out of 60. Now, the greatest common factor of 45 and 60 is 15. I could divide top and bottom by 15, okay? But I'm going to show you what most of you did, okay? If you only want one step in simplifying, you pick the greatest common factor. But most of you might not know that the greatest common factor is 15, so you probably picked 5 because you noticed these were multiples of 5. So 45 divided by 5 is 9, and 60 divided by 5 is 12. And then you notice I don't see 9 12s, so I can go one more step, divide by 3, and the answer is 3/4. Now, a common mistake here is people looked at the spinner and probably picked, there are 4 multiples of 4, so you probably picked C. Okay, so be careful and make sure you know what they're asking for. Experimental is the experiment. Theoretical is what's supposed to happen. That's what's on the spinner, in the bag, in the box, in the container, or in the deck of cards, or on the die, or on the coin. Okay? All right, that concludes our video on theoretical and experimental homework. Please let me know if you have any questions and have a wonderful day.